Hello everybody, CozyAzeroth, aka Zachary Fruling here with another type-in program from the user's reference guide for the TI-99 for a home computer. And without further ado, let's dive in. First, let's get into TI Basic. I've got the user's reference guide pulled up here, and we're on to character definition. I'm going to scroll down and give you a screen. So if you remember, the TI-99 4A has the ability to create custom characters, basically what we'd call a sprite now. They weren't technically sprites back then, but an 8x8 grid of pixels where each pixel is either on or off. And we've got a character designing program here, a character definition program. So what we're going to do, we're going to go through and we're going to read the beginning, and then we're going to read this basically description one paragraph at a time, one chunk of code at a time. We're going to type it into an emulator and get the program working in Classic 99. So let's, excuse me, a little choked up, excuse me. Let's dive in. This program allows you to define special graphics characters using the computer. An 8x8 grid is displayed on the screen. You then choose which dots to turn on and which to leave turned off. After the character has been designed, the program determines and displays the hex string to be entered in the CozyAzeroth statement. Okay. The first chunk of code is pretty long, so let's read the description and we'll start typing it in. These statements define the off dot character, line 120, and the on dot character, line 130. Black is used as the foreground color, on dot, and white is used as the background color, or the off dot. The screen is then cleared, and the labels needed on the screen are displayed at the necessary locations. Note that the subroutine beginning at line 770 is used to print a string horizontally on the screen, and the subroutine beginning at line 820 is used to print a string vertically on the screen. The R loop is used to place the 8x8 grid, all dots turned off on the screen. Okay, let's dive in. Start at line 100, rem, remark, character definition. Okay, 110. DIM B, and it should be 8.8. This is our 8x8 grid. Basically, going to use an array here. Oop! I meant to. Let's type new. Let's start over. I forgot to put the line number in. Okay, dim. It was B, right? Or no, dim B 8,8. That looks right. Okay, 120. Call CHAR. $100, so that's character number 100, and it's just a string of essentially 0. $130. Call CHAR. $101. And this is all Fs. Should be 16 of them, right? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. $140. Call color 9, 2, 16. $150. Call clear. It's funny, I usually clear the screen before I do all this stuff, but you know, it's just a stylistic choice. $160. M string equals auto character definition. $170, y equals 3. 280. X equals 4. $190. Go sub 770. $200 M string equals one, two, three, four, five, six, seven, 8. $210, Y equals 8. $220, go sub 770. $230, go sub 820. $240 M string equals 0 equals off equals white. 0 equals off equals white. 250. Y equals 22. 260. X equals 4. 270, go sub 770. 280. Okay, M string equals 1 equals on equals black. Yep, that looks right. 290, Y equals 23. 300. Go sub 770. 310. For R equals 1 to 8. Okay, actually, let's read the next description here. This loop allows you to turn the dots either on or off. To turn a dot on, press the 1 key. To leave a dot off, press the 0 key. The cursor starts in the upper left corner, row 1, column 1 of the grid. Each time you press a key, the dot is turned on or off, and the cursor moves to the next position. When the end of a row is reached, the cursor automatically moves to the next row. When the last dot is turned on or off, the program continues to determine the hex string. Line 430 performs a logical OR. If the key you pressed was not a 0 or a 1, the program transfers back to line 370 to accept the new key input. Errors in the grid can be corrected before the last dot, row 8, column 8, is entered by using the left arrow and right arrow keys. If either of these keys is pressed, then the program transfers to the subroutine beginning at line 870. The subroutine moves the cursor in the appropriate direction into the next row, up or down, as necessary. Okay, so where do we leave off? Line 310. For R equals 1 to 8. $20. Call HCHAR. $8 plus R, comma, 4 plus C, comma, 30. $330. Next R. $340. For R equals 1 to 8. $350. for C equals 1 to 8. $360. Call HCHAR. Oh, wait a minute. I think I made an error on line 320. I sure did. I was looking at the wrong line. Okay, hold on. Let's back up. 320. Let's retype 320. Call HCHAR. I just realized I was looking at the wrong line. 8 plus R, comma 5, comma 100, comma 8. Okay, let's bust out the program. Okay, now line 360. Call HCHAR. Make sure I'm looking at the right line. 8 plus R. 4 plus C, comma 30. Okay. 370. Call key. Zero, comma key, comma status. $380. If status equals 0, then 370. That's just waiting for a key press. Okay, 390. If key, let's see here, if parentheses, key, is not equal to 8. Oh, we've got a parentheses here. Plus, oh, no space. Just in modern programming languages. Plus, key is not equal 9. Equals -2. Then 420. Go sub 870. Hold on here. 870? Yep, 870. 410. Go to 360. $420. Key equals key minus 48. $430. Okay. If let's see here, key is less than 0. Plus key is greater than 1. It's less than or equal to, oh, I saw a typo. Oh no, 390 is okay. 430, yes, less than or equal to -1. Less than or equal to -1. Then 370. Just double check that. If key is less than 0, plus key is greater than 1, less than or equal to -1, then 370. Yep. Okay, 440. B, comma R, parentheses R, comma C, equals key. $450. Call HCHAR. 8 plus R. 8 plus R. 4 plus C. 100 plus key. And that's all. Yep. 460. Oops. Next C. 470. It was next R. Yep. Okay, let's read the next chunk. These statements determine the hexadecimal code for each row in the grid. When the code is determined, character 102 is defined to be the character shown on the large grid. The newly defined character is then displayed on the screen, row 8, column 20. The character is also displayed in a 3x3 pattern. Then the hexadecimal code defining that character is displayed. Lines 630 through 720 print instructions on the screen for you to define a new character. If you are finished defining characters, press Q and the program stops. If you press any other key, the program transfers to line 140 to clear the screen and begin again. Okay, 480. Hex string equals, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay, 490. M string is blank. $500. For R equals 1 to 8. $510. Okay, here we go. Be careful here. Low equals B. Parentheses R, comma 5. Times 8 plus B. Parentheses R, comma 6. Times 4 plus B of R, comma 7. Times 2 plus B of R, comma 8. I think I saw plus 1 there. Plus 1. And 520. High equals excuse me, I got a little message here. Oh, just someone favoriting cross-stitch patterns. Okay, high equals B of R, comma 1. Times 8 plus B of R, comma 2. Times 4 plus B of R, comma 3. times 2 plus b of r comma 4 plus 1. Okay, let's make sure we got this right here. High equals b of r comma 1 times 8 plus b of r comma 2 times 4 plus b r comma 3 times 2 plus b r comma 4 plus 1. That looks right. 530. Okay, m string equals m string and seg string, the string segment, hex string, comma high, comma 1, and string segment, hex string, comma low, comma 1. Oop, forgot a parentheses there. There we go. Let's double check our work here. 530. M string equals M string plus string segment, hex string, comma high, comma 1, and string segment, hex string, comma low, comma 1. Yes. So 540, next R. 550, call CHAR. (102), comma M string. 560. Call HCHAR. It displays it on the screen. 820, 102. (570). For R equals 0 to 2, (580). Call HCHAR. 12 plus R, comma 20, comma 102, comma 3, (590) next R. Okay, a bit more typing to do here. 600. Y equals 16. (610). X equals 12. 620. Go sub 770. 630. M string equals press Q to quit. (640), Y equals 18. (650). X equals 12. 660. go sub 770. $670. M string equals press any other. $680. Y equals 19. $690. Go sub 770. $700. M string equals key to continue. $710. Y equals 20. $720. Go sub 770. $730. Call key. Zero comma key comma status. $740. If status equals 0, then $730. $750. If key is not equal to 81, then 140. $760. Stop. $770. For I equals 1, 2, length of M string. $780. Code equals ASC of string segment M string comma I comma 1. $790. Call HCHAR. Y comma x plus I comma code. $800. Next I. $10. Return. $20. For I equals 1 to length of M string. Typos. There we go. Okay. Scroll a little bit. 830. Code equals ASC. Okay. String segment. Sorry, what line around 830? M string, comma I, comma 1. Okay, 840. Call HCHAR. Y plus I, comma, X, comma, code. 850. Next I. 860. Return. 870. Call HCHAR. 8 plus R. Four plus C, comma, 100 plus B, B is our array, R, comma, C, close and close. 880. If key equals 9, then 960. Okay, 890. C equals C minus 1. 900. If C is not equal to 0, then 1020. 910. C equals 8. Okay. 920. R equals R minus 1. 930. If R is not equal to 0, then, sorry, what line? 930. If R is not equal to 0, then 1020. 940. R equals 8. 950. Go to 1020. 960. C equals C plus 1. 970. If C is not equal to 9, then 1020. 980. C equals 1. 990. R equals R plus 1. 1000. If R is not equal to 9, then 1020. 1010. R equals 1. And finally 1020. Return. Okay. We should be done. Let's run it and see how we did. Gotta take a minute to scan this program. Auto character definition. Alright, so far so good. Alright, so basically we can go from, yeah, we can go up, down, left, right. Can't go up, down, it's just right, right, right. So let's just create a little, oh yeah, okay, oh, we might have missed something there. Okay, I think we have a little... What's in the program? It must be in line 130. That's where the on character is defined. Might have missed an F there. Time for a little bug fixing. After we do the bug fixing, we'll run it again. Okay, list 130. Okay, 130, call CHAR 101. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That was it. We missed an F. Let's clear the screen, and let's run the program. Oh, we forgot to do an in parenthesis on line 130. Okay, list 130. I see what I did there. 130, call CHAR 101. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, quote, and an in parenthesis. That should fix the problem. Let's run the program again. I think it should work correctly this time. Okay. Well, let's just make a little like an X on the screen. So 1, 1, 1. So we're turning 1 to turn the dots on. Okay, and there's our hex code. 8142-2418-1824-4281. And you can see it's I like this program because it shows you what one character will look like, but it also shows you what a little grid, in case you're trying to make a tileable grid, will look like. So let's take a screenshot of that. You know what I want to do? Press any other key to continue. What I want to do is I want to go up to chapter 5 of this. Oh, I'm sorry, wrong book actually. Hold on one second here. I want to go to the user's reference guide. Excuse me, beginner's basic. And I want to go to chapter 5. Because chapter 5 of this book has the little picture of Mr. Bojangles. We're going to make a little picture of Mr. Bojangles here. There we go. Let's draw Mr. Bojangles. Okay, so we've got on, then on. Come over here and we have on, and this is part of the head, part of the arm. Okay, we have this big square block in the middle here, so come over here, boom, 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 boom. Boom, 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 boom. Okay. Then we just have two little legs on the guy. Oops, I accidentally hit one. There we go. Actually, did I make a mistake there? Oh, I think I just accidentally hit one. So, okay, there we go. Oh, there's a bug. Look, when I hit back in certain places, I gotta check. There might be a bug somewhere. Look, it's accidentally turning them. I'm not sure. It's when we hit the left arrow, we're getting a weird bug. Yeah, so we'll have to check that out. So let's check our hex code. 995A, 3C, 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 2424. So we get the hex code is right, but we need to end the program because we're getting a weird bug. Let's see where that bug might be. Here under character definition. I'm not sure I'm going to be able to figure this out, but it's when we hit the left arrow key. Transfers to line 870. Okay. Okay, 870, call HCHAR, 8 plus R, 4 plus C, plus B, R, comma C. Okay. If key equals 9, then 9. Okay. Let's list. It's the only bug that I've noticed, so I must have made a mistake here somewhere. Okay, let's check line 870. Call HCHAR, 8 plus R, 4 plus C, 100 plus B, R, comma C. Okay. 880, key equals 9, then 960. 890, C equals C minus 1. 900, if C is not equal to 0, then 1020. 910, C equals 8. 920, R equals R minus 1. 930, if R is not equal to 0, then 1020. 940, oops, excuse me. R equals 8. 950, go to 1020. 960, C equals C plus 1. 970, if C is not equal to 9, then 1020. 980, C equals 1. 990, R equals R plus 1. So 1000, if R is less than or equal to 9. Excuse me, if not equal to 9, then 1020. 1010, R equals 1. 120, okay, so we're missing something somewhere. I think we're going to have to list out one chunk at a time. Let's do lines 100 through 300 first. Okay, let's look for mistakes here. So 110, dim, B of 8, comma 8. 120, call CHAR. 100, comma, that looks good. 130, okay, that's the line we fixed. Line 140, that looks fine. 150, 160 is fine. 170, y equals 3, x equals 4. 190, go sub 770. 200 looks fine. 210, y equals 8. 220, go sub 770, 230, go sub 820. Message is fine. 250, okay, those look fine. 270, go sub 770. 280, okay, that looks fine. 300 is go sub 770. Yep, so let's list 310 through I don't know. We'll just do them in chunks of 100. 310 through 320. or 319. Oh, I meant, that's silly me. List 310, actually 300 to 390. Okay, so somewhere we've got a mistake, I'm sure, or there's just a bug in the program, which could be. Okay, 300, go sub 770, 310 for r equals 128. Okay, 320, call HCHAR, 8 plus r, ooh, comma 5, comma 100, comma 8. That looks right. 330, next r, 340 for r equals 1 to 8. 350 for c equals 1 to 8. Yep. 360, call HCHAR, 8 plus r, 4 plus c, comma 30. 370, call key 0, comma key, comma status. 380, if key is less than is not equal to 8 plus key is not equal to 9 equals -2, then 420. Okay. List 400 to 490. Oh, list 4. I always forget the syntax here. To 490. There we go. Let's see if we can find our typo. 400, go sub 870. 410, go to 360. 420, key equals key minus 48. 430. Be careful here. If key is less than 0 plus key is greater than 1 is less than or equal to -1, then 370. Okay. 440. B of r comma c equals key. 450. Call HCHAR, 8 plus r, 4 plus c, 100 plus key. Okay. 460, next c, 470, next r, 480, hex equals blah, 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 blah. That looks good. 490, M string is blank. Okay, list 500 to 590. We will find the bug, I'm sure of it. Or there isn't one, and it's just a buggy program that could be. 500 for r equals 1 to 8. Okay, 510, we've got to be careful here. Low equals b, r comma 5, times 8 plus b, r comma 6, times 4 plus b, r comma 3, times 2 plus b, r, oh wait, for which line I'm on here. Oh yeah, this might have been the problem. I might have been looking at the wrong line. So we're on line 510. Low equals b, r comma 5, times 8 plus b, r comma 6, times 4 plus b, r comma 7, times 2 plus b, r comma 8, plus 1. And that looks okay. Okay, 520 now. High equals b, r comma 1. Okay, times 8 plus b, r comma 2, times 4 plus b, R comma 3 times 2 plus B, R comma 4 plus 1. That looks pretty good. Okay, 530 M string equals segment hex string comma high comma 1 and segment hex string comma low comma 1. That looks fine. 540 next R. 550 call CHAR 102 comma M string. 560 call HCHAR 8 comma 20 comma 102. 570 for R equals 0 to 2. 580 call HCHAR 12 plus R comma 20 comma 102 comma 3 and 590 next R. Okay, so list 600 to 690. Okay, Y equals, this all looks pretty good. Y equals 16, X equals 12, go sub 770, Y equals 18, Y X equals 12, go sub 7, yeah, I think that all looks okay. Let's just run the program. Maybe it forces you to kind of check your work as you go. Maybe it's just because there was already black there. I haven't been able to find a typo in the program. So it's looking pretty good. I'm just hitting 0 now. And I set everything to off. It's off by default, so it should know when I let's try our Mr. Bojangles again. So we had on, off, off. Oops, excuse me. Off, off, on, off, off, on. Then we had off, on, off, on, off, on, off, 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 on, on, off, 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 on, on, off, 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 on, off, 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 on, off, 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 on, off, on, off, off, on, on, off. Okay, there's our Mr. Bojangles. Okay, so I might have just been thinking there was a problem that there isn't. Let's go back to Beginner's Basic. Do we have... There we go. Let's do our little dancing Mr. Bojangles. Let's do this one. Okay, so we've got off, 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 on, off, off, off. Second row, we've got on, off, off, on, off, off, on, off, off, on. In the third row, on all the way across. That's going to be FF. And next row, off, off, on, off, 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 on, off, off, on, off. Row 7, okay, off, on, off, on, off. On the right side right here, off, on, off. Off, on, off. Last row, off, on, off. And then down here, off, on. Okay, let's just check our hex code, see how we did. Make sure it's getting the hex code right. 1899. There's our two Fs, FF, 3C, 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 and 2221. All right, so the hex code is correct. Let's do the other version of Dancing Mr. Bojangles. Okay, so we've got on, off, on, off, on. Okay, off, on, oops, sorry. So we got on, off. Row 3. Okay, working on the body here. So off, on, off, on, off, off, on, on, off, off, on, off, on, off. Now let's do the legs. Off, on, off. On the right side, off, on, off. And on, off, on, off. Okay, so let's check our hex code now. 99, 5A, and a bunch of 3C, 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 and 4484. And so yeah, it's getting the right hex code. I think maybe we just had a slight misunderstanding. I think maybe I was moving left on a place where there was already a black character there, so it looked like it was making a mistake as it was going to the left, but it really wasn't. Okay, well that's auto character definition for the Texas Instruments TI-99 4A from the User's Reference Guide Type-In programs. For archival purposes, let's scroll up and look at the cover of the book. It's the cover of the User's Reference Guide that came packaged with the TI-99 4A. And I'm very excited because up next, I'm not going to do it right now, but after character definition, we've got my favorite type-in program from the User's Reference Guide, Graphics Match. So that's coming up next, so be on the lookout for that stream. If you're watching this on Twitch Live, be sure to check out my YouTube channel. You can find me under Zachary Fruling or CozyAzeroth. And if you're watching this on YouTube, check out my other TI-99 4A videos on YouTube, so likewise on my YouTube channel, and check out my Twitch stream under CozyAzeroth, where I stream some TI-99 4A content, some retro gaming, a lot of World of Warcraft, some other modern games, a little bit of everything. So follow me there on Twitch, follow me on YouTube, and remember to like and subscribe. Thank you very much. I really appreciate it. And I will be back soon with another TI-99 4A retro programming stream before you know it. I'm going to end on a little screenshot of our character definition screen. All right. Thank you very much, everyone. Have a good day.